we're ready to begin our tech talk today on streamlining BOM management with Teamcenter. Now, questions will be answered live at the end, but please go ahead and enter them into the chat as they come up. Our presenter today is Ronik. Ronik has been with PROLIM for 3 years as a Teamcenter application engineer. He is based in our Cincinnati office. Ronik, the tech talk is now yours.
Hello everyone, welcome to our today's tech talk on streamlining BOM management with Teamcenter. Today we'll go over some of the BOMs. We'll see the challenges organizations are facing. We'll go through what is a design BOM, engineering BOM, the differences between them, why separating these design BOM and EBOMs are important, and lastly we'll see how with the help of Teamcenter we can generate an aligned engineering BOM from a design structure. So, due to the increasing globalization of product development and manufacturing, companies often design product in one or more locations while manufacturing them entirely in a different region. This distributed model requires cross-functional collaboration and adoption of flexible BOM structures that can accommodate diverse workflows. So each department, whether engineering, manufacturing, or services, interacts with BOM data in a way that reflects its unique responsibilities. These interactions may be creation, modification, or consumption of BOMs, leading to development of multiple BOM structures and user interfaces tailored to the specific functional needs. Organizations may adopt different strategies for structuring BOMs. Some begin with a design BOM and later adopt to an engineering BOM. Others start with an engineering BOM and derive a design BOM from it. Alternatively, some companies develop both these structures simultaneously, ensuring alignment from the outset. As the product progresses from concept to service, various BOM UIs are generated. These interfaces are typically managed through distinct systems and processes and are often interconnected via integrations technologies such as APIs or middleware. Each interface is designed to meet a specific requirement for the function it supports, be it design, production, or service. Throughout the product lifecycle, BOMs undergo a process of evolution and enrichment. Initially, they may only have positional data such as part locations in the design BOM. Over time, they may enhance with master data including part numbers, supplier information, maintenance schedule. For example, there's MBOMs, manufacturing BOMs, and service BOMs. Next, what are the challenges the customers or organizations are facing when they have so many different BOMs with different systems and different UIs, and they all are interconnected through some sort of integration? One of the most common obstacle is the existence of data silos. Design and engineering team often work in isolation, using separate tools and systems. This fragmentation can be resolved by unifying both disciplines within a centralized PLM system, that is Teamcenter. Without a shared understanding of product structure, inconsistencies arise. Establishing a single source of truth ensures that all stakeholders are working from the same and accurate product definition. There may be manual entries and transfer errors, which leads to inefficiency. By automating BOM synchronization, organization can significantly reduce rework and eliminate common mistakes caused by data transfer. So Teamcenter has the capability of aligning design BOM and engineering BOM and keeping them up to date to the latest structures. Then the delay in propagating change across teams can slow down development. A connected system enables faster and traceable updates across both design and engineering BOMs, improving responsiveness and accountability. Some of the companies or organizations have complex variants. As product configuration grows more complex, managing variants becomes a challenge. Effective configuration controls with a clear separation between design, intent, and constraint is essential for maintaining order and flexibility. So Teamcenter has product configurator, which can be used in this case. Now, what is a design BOM? A design BOM is a CAD-centric, usually built from the CAD tool. It includes all structured list of components, parts, sub-assemblies, and assemblies, and usually designed by the designer from the CAD tool. Whereas an engineering BOM defines all items, parts, components, sub-assemblies, assemblies in the product designed by an engineer that are necessary to build the finished product or the product line. These parts will include software parts, electrical parts, electronics, mechanical, and documents. Whereas in design BOM, it does not include documents or software parts. Engineering BOM may also include non-geometric parts such as sealants, lubricants, colored parts, or something similar parts like these. So customers typically manage their EBOM in a separate system from Teamcenter, either a vendor ERP like SAP or a homegrown part bill of material system. Unfortunately, each silo system must have its own change management and configuration capabilities, and they are not aligned together when you have EBOM and design BOM in different silos or different systems. Also, once the data passes out of the design silo, the visibility into the neighboring silo is extremely low or usually none. The lack of visibility across silos and disjoint business processes across silos are key blockers to achieving current market demands. With Teamcenter, you can have both EBOM and the design BOM in the same place, and you can have them aligned automatically or manually at any time and have the latest structure. So how is design BOM different from an engineering BOM? Design BOM is a CAD-centric that is authored by the designer in the CAD tool. It has the master of 3D geometry, CAD drawing, and models. It will have the logical semantics, logical connections, and the entire structure will be built in the CAD tool. Whereas the EBOM, it is a list of all the parts, sub-assemblies that include software parts, electrical, electronic, mechanical, or documents. It will also include colored parts, alternates, and substitutes. It can also include non-geometric parts like sealants and lubricants or packaging. Also, the EBOM will be a buildable configurations with the help of rules and constraints. Now, why is it important to separate the design and the engineering BOM? It has several advantages. It enables the independent evolution of part and design lifecycle. This allows the BOM engineers and CAD designers to structure data as per their respective needs. For example, a single design can represent multiple parts. In this case, for example, you have a rim of a wheel. It is a single design, but it can have multiple colors or multiple materials. So it's a single design but multiple parts. Also, a part can be added even if there's no design for it. So there are various reasons why these needs to be separated out. EBOM and Design BOM have different needs, and combining into a single BOM forces compromise. EBOM also provides a separate area to finalize prior to production. Engineers and designers have different roles and responsibilities and different processes, so it gives them more independence and removes unnecessary responsibility when we separate these two BOMs out. So, Design BOM and EBOM alignment. Using Teamcenter, you can automatically generate an engineering BOM from a design BOM. The two BOMs are automatically aligned with each other in Teamcenter. An aligned part shows what the part will look like independent of its usage in the product. So there's automated alignment or guided alignment. You can pick and choose within Teamcenter. You can have unified changes, and you can also have 3D BOM visualization for both these BOMs. Now here's an example of aligned design BOM and engineering BOM. So we have a wheel assembly on the left. This is a design BOM authored by a designer in a CAD tool, and then on the right we have the newly generated engineering BOM through Teamcenter. So the red lines here show the design part alignment, and the green ones show the design occurrence and part occurrence alignment that are actually the position in the product. So an aligned part occurrence shows where the part will be positioned in the product. These aligned BOMs will continue to evolve throughout their life cycle. You can ensure that the BOMs are synchronized with each other using automated or guided updates. In some cases, changes to one BOM do not impact its corresponding BOM. For example, the finish of a part changes, resulting in a design change, but the change does not impact its function or its physical fit with other parts to warrant a change to the engineering BOM. After alignment, you can generate mockups from engineering BOM. Visualization helps conceptualize and develop the product. These digital mockups represent the actual buildable products, product variants, more realistically than a mock-up derived from a design BOM. This is because the CAD designer explores many alternatives during the development process, resulting in several variants of the product, and the design BOM for all these variants. Not all of them are commercially relevant. Teamcenter uses engineering BOM of the product to generate and visualize its commercially relevant variant. So to summarize, maintaining a design and an engineering BOM separately has several benefits that helps manage complex products. You can ensure that the two remain synchronized with automated BOM updates and alignments using Teamcenter. We also talked about how multiple designs can have same parts and a single design can have multiple parts. So here's an example. In the first case, we have multiple design for same parts that are flexible parts. It could be springs or tubes or harnesses. They can have multiple design, but the part is same. In the other case, where we have single design but multiple parts, we can have, in this case, we have a wheel which has multiple colors, black or red. So it's same design but multiple parts. Let us take a look at design BOM and engineering BOM in Teamcenter now, and how the alignment is done for them. So I'm logged into Teamcenter right now, and let's open an assembly that the designer created. This does not have an engineering BOM right now for it. It is a simple wheel and tire assembly with 3 child components. If I look at the details, I'll see that I do not have any aligned engineering part for this. Even if I go over to the alignment view, we'll see we don't have any engineering BOM for this. So now there are 2 ways of generating an engineering BOM from this, either through a workflow or through a command. So the generate part EBOM will automatically generate an engineering BOM for this. We can either use this, or we could use create engineering BOM command over here to generate a engineering BOM for this design BOM. For now, I'll use the workflow to generate the engineering BOM for this. It's a quick 1-step workflow, and once it's completed, we will see that we have a aligned part for this. And if I now open the alignment view, I'll see the engineering BOM for this wheel and tire assembly. So we talked about design and part alignment, and design occurrence and part occurrence alignment. So here we'll see that both of these are aligned right now. You can also see a 3D of both the design and the engineering BOM. In the details, we can see each component of both design and part are aligned together. In the aligned part and aligned design section here. This goes for all the child components. So this is how we can generate the engineering BOM from design BOM and work separately with design and EBOM. The engineer can author the design BOM, the designer can author the design BOM, and the engineer can author the engineering BOM. Now let's pick another example. This time the designer has updated the design BOM. He's added 16 screws to the assembly. These are all 16 screws. And if I go and see my aligned engineering BOM for this, we'll see that we do not have those screws aligned with the engineering BOM right now. We can also see the alignment status. Everything that's checked means that it has been aligned with the engineering BOM, and the rest over here we do not have them aligned. Let's take a look at this in 3D and see that these are the screws. We don't have any screws in this assembly, whereas in this assembly we have these 16 screws here. So let's go ahead and try to align these 16 screws into our engineering BOM. Again, either we could use a workflow, or we could use the command to automatically update the engineering BOM. It could be a guided update or an automatic. So I'll just go ahead and do an automatic update here. So what this will do is add those 16 screws to my engineering BOM and pack them together. So now we can see we have these 16 screws here in our engineering BOM as well. Another thing we talked about the design BOM and engineering BOM earlier was the authoring of the CAD model drawing is all in the design BOM. If I go over to the attachments of the design BOM, I'll see the UG master and CAD model for this, and for each and every part I'll see the UG master for every child component. Whereas in the engineering BOM we do not have the master files here. It's only referencing the design and pulling the design from the design BOM. For all the child components also we do not have any CAD master here. So with the help of design and part alignment and design occurrence and part occurrence alignment, we can see the assembly structure in engineering BOM. So with the engineering BOM and design BOM separation, the BOM engineers and CAD designers can structure data as per their respective needs. They can add flexible parts that have multiple designs but single part, or they could add a part that has multiple parts but a single design in case of wheel with different colors or material. We can add bought out parts which do not have a structure but are represented just as a single part and do not have part breakdown. That can be done with part BOM separation. This allows the engineers to configure and build their engineering BOM using rules and constraints and pass it on to manufacturing for production. With this, we'll conclude our tech talk today.